All right, everybody, I'm doing question number 4 as our example. So there should have been a list, let me just get it back up, of redox practice questions, and I've been told that you guys have done some of this with Ms. Mudford. So you guys have said that you've done question 1 and 2 with Ms. Mudford and number 6. Just 1 and 6. Okay, so you guys still need to work through questions 2, 3, 4, and 5. Shall I do question number 2, or do you guys want me to do question number 4? All right, let's just do question number 4. All right, so I'm just going to make a note on my sheet which question number 4 is describing to us. So we have copper being added to, I'm just copying it, it's still on the board. Yeah, I'm copying it onto my piece of paper. Copper is added to concentrated nitric acid. The solution turns blue. So we have solution observations. It's going from colorless to blue. We also have the brown metal disappearing. And then the last thing happening is that we get brown fumes, or brown bubbles. Are we okay with that so far? So we're looking at this question here. All right, I'm going to switch over to the document camera because I do have it copied down there. All right, we good? No, it's there. It's the same thing. I just wrote it shorthand. All right, copper is added to concentrated nitric acid. The solution is going from colorless to blue. My brown metal is disappearing, and then I have brown bubbles forming. Come on, document camera, you can do it. Stop looking. People don't like that. All right. Are we okay so far?
Yes.
All right. So let's talk about what you need to do for the achieved. The achieved is writing down your observations and making sure you link it to different things. So let's just process the question first, and then we'll start writing things down. Does that sound like a good plan so far? Yes? All right. So what I want to do, those little sentence statements are what we're going to be giving you guys tomorrow. So just be mindful, those are really good practice questions. So we'll give you a list of what you're mixing together. We'll give you the observations. You just got to figure out what's going on. Okay? So copper is the first thing I notice on here. So what I'm going to be looking for is Cu, because that's my copper. And that's that pink brown metal. So that helps me identify what that brown metal that I added to. I also notice that that brown metal disappears and that my solution turns blue. So from that information, I can see that that's probably the copper 2 ion, because that's what's blue in solution. So those are probably the two things I'm going to be using for my copper. And when I look for equations, I can see it right here, the copper 2 ion and the copper. So I'm going to be using this equation in some sort of setting. Are we good with that so far? All right. Next thing I'm looking for is the nitric acid on my list. So that would be hopefully on my list. See if I can find it on this side. Here we go. HNO3 concentrated to NO2. So again, we're going to be looking for those items on my list. So I can see that NO3 is on there. It's aqueous and it's colorless. And the other thing that I see on there is going to NO2, and that's brown. And does that match the observation that we said about brown fumes? Yeah. So everything should back itself up. Are we good with that so far? So now that I know that information, I can start writing down my observations. So, observations for the solution. It's going from colorless to blue. You don't need to write full sentences. You can just write things really simple. So if I'm thinking about what is causing that blue color, what's causing that? Looking at our list, the copper 2 ion. So I know that there is my Cu2+. All right, I also saw my brown metal disappeared. So what was my brown metal? The copper. And then I also saw that we had brown fumes formed. And then what was that? If I look at my list over here, my brown gas was nitrogen dioxide. So you see how I'm figuring out what everything is? Now, if it's in red, that's what we need for the achieved. Are we good so far? Yes. All right. Before I figure out which is my oxidation and reduction reaction, what I can do is just regurgitate information that I know is memorized to make sure I get the achieved. So when we're talking about reduction reactions, is reduction gain or loss of electrons? Gain. What should happen to my oxidation number? Should it go up or down? Down. All right, when I'm thinking about oxidation, is that gain or loss of electrons? Loss.
Loss.
All right, what happens to the oxidation number?
It goes up.
It goes up.
Yeah.
So I'm just regurgitating information. Just giving the memorization of my terms. All right? Sounds good?
Yeah.
All right, last thing I then need to do is I need to figure out which is the reduction reaction and which one's the oxidation reaction. So what I will then suggest you guys do is you go back to the resource sheet and we look at the two things that we pointed out. Now remember, for the redox pairs, we should always have something from this side of the list and one from the other side of the list. Because one's going to go forward, and that's my reduction reaction, and one's going to go backwards, and that's my oxidation reaction. So we know as our starting products that we had nitric acid, which is that there, and we also know we had copper metal as our starting bit, because we say in the beginning of our sentence, copper added to concentrated nitric acid. So do we see how I pulled that information out? Okay? So if I'm going in this direction, that is my reduction reaction. So my reduction reaction, my reactant, is the nitric acid. I will also accept if you wrote NO3-, because that's how it's listed on this side. And then it is becoming NO2. So all the answers are there. All right, since this is the reduction reaction, that makes this an oxidant, because remember the words swap around. And I just write down what I have for my reactant, so the nitric acid. And that's that first one filled in. Are we okay so far?
Yes.
All right. Oxidation half, Remember, we're going backwards for oxidation, so I start with the copper and I become the copper 2 ion. Now, since this is my oxidation, that makes copper what? Reductant. Cool. All right, just going to zoom out so you guys can see the whole big picture of everything. So everything that I've written in red is all you need for the achieved. And in fact, you don't need both of these for achieved. It's an or option. So basically, you're giving me a definition of oxidant and reductant. Sorry, oxidation and reduction. You are figuring out the reaction, and you are stating the observations. So that's all you need to do for the achieved. You don't have to worry about any of the equations if you are only aiming for an achieved. Easy peasy?
Yep.
All right, make it a little bit harder?
No.
Shall I explain the mirror, or do you guys just want to stop there? Let's go to the merit. All right. So what I'm going to do is I'm going to do the easy version for merit, so you guys know what you can do as the bare minimum, or if you're trying to do things like not too bad. Right. Personally, I like to go to the equations and then fill in my justifications. Let's go with the easier of the two equations, and that's going to be the copper one, because I know there's not going to be any waters to balance or oxygens or hydrogens to balance. So I personally like to line up my equations so that way they have all of the arrows in the center, so I can easily tell what's reactant and what's product. I'm starting with the copper, and I'm going to the copper 2 ion. So that's the first bit of my equation. So when we're going through the steps, first thing we ask, is the reactive species balanced? Do I have the same number of coppers on each side? Yes, because it's 1 and 1. That is a +2. That's the charge. It's not a number of copper. All right. Do I need to balance for any oxygens? No. Do I need to balance for any hydrogens? No. So I can go straight into the electrons now. All right. When I'm looking at the electrons, there's several different ways you can think about it. The way I like to think about it is comparing the charge on each side and if the charge is balanced. So the charge on this one is 0. What's the charge on that one? 2. So I need to add how many electrons? 2 to that side, so that way it brings the number down to 0. So I add 2 electrons. And again, if you want to state observations in the equation, you can. So I could state that this is a solid, and that's brown. I can state that that's aqueous, and that's blue. So that's another way you can link in your observations to make sure you know what you're doing. All right, let's then take this information and put it into my justification. So how many electrons did I lose for that oxidation reaction? 2, so now I'm specifying it. Okay, oxidation goes up. How many did it go up by? 2. Goes up by 2. What was my number change? What was the oxidation number of this guy? 0, 2, 2. And remember, just do +2 because we have to change it. When we're doing oxidation numbers, the positive or negative goes in front. When we're doing charges, it goes behind. All right? Here's some good news for you guys. That is enough for a merit. Yep. That's the easy merit one. No. So merit, I just need to see one balanced equation and one justification. 1/2 balanced equation and one justification out of the 2. I would suggest you do the other one because it gives you 2 chances for merit. And then if you're going for excellence, it's very easy then to go to the next step. All right, shall we do the next one?
Yes.
All right. Once again, we line up our equations. We're going to keep it simple. We'll do nitrate, and then we'll do NO2. That I know is aqueous, and that's colorless. That I know is a gas, and that is brown. Nitric oxide. All right, I'm still writing this in blue because remember it was one of the two half equations you need to get for merit. All right, so first step, is the nitrogen balanced? How many are on this side? 1. How many are on this side? 1. So the nitrogen's balanced, we can leave it alone. Do you want me to go through that again? Okay. Nitrogen on this side is 1. Nitrogen on that side, still 1. So it's balanced. All right, next thing I check is my oxygen. Are the oxygens balanced? That one has how many? That is 3. How many are on this side? 2. So it's not balanced, is it? So I need to add what?
5 electrons.
We're not doing the electrons yet. That's the last step. All right, how do I put in oxygens? Add water. How many do I need to add? Just the 1. If I want, I can do states as well. All right, do we see how we got there? All right, but I created a problem now, didn't I?
Yes, you did.
What did I add?
You need 2 hydrogens.
I added hydrogen, so we're doing the opposite side, plus 2H plus. That'd be aqueous. Which makes sense because we're dealing with an acid. And these are all colorless, colorless, colorless. All right, when I'm looking at that reaction, last thing I need to do is balance for my electrons. So when I look at this side, do we see how the charge is 0?
Yeah.
On this side, what's the charge?
+1.
Plus 1, because there's 2 here, minus 1, plus 1. So how many electrons do I need to put in that side? Just the 1 electron. Do we agree?
Yes.
Okay. So when I go to my justification then, let me zoom out a bit. All right. So we've gained 1 electron. But the other thing I need to check is how did my oxidation numbers change? So we got to figure that one out. So what's our oxidation number for nitrogen? So we have 3 minus 2, so that's -6, minus 1, so that makes it +5. Do you want me to show you the mathing? Okay. I'll grab another color. All right, NO3 minus. So we need to do something called oxidation math, don't we? Sorry, it keeps flickering. All right. Oxygen, based off the oxidation number rules, is going to be -2. Do we agree?
Yes.
All right, I have 3 of them, so that equals -6. So I have my nitrogen plus -6 equals -1. N equals +5. Cool? No? Brooklyn's shaking her head. All right, there's a list of oxidation rules. I want to hunt them up for you. Oxygen is -2, based off of those rules. I have 3 of them, so I need to multiply by 3. And so the total number that I get from there is 6. Now, with that -6, whatever nitrogen is, they need to add together to be -1, which is the charge of the polyatomic, which is using another one of the rules. Nitrogen must be +5 for that to work out. Just looking at some algebra. Cool. Moving on. You guys can do some practice. All right, so that one's +5. And then this one, NO2, should be +4. Do you guys see how I did that mental math? Or do you need me to show you how I did that working?
No, it's all right.
Oxygen's -2. I have 2 of them. Overall charge needs to be 0 because it's a molecule. So -4 plus +4 equals 0. So when we're doing our justification then, it's gained 1 electron. The oxidation has gone down by 1. We've gone from +5 to +4. So everything should back each other up. The good news for the merit is that I need a justification for either or of the sections. So either you justify the reduction reaction or you justify the oxidation reaction. You get 2 chances to do that. The other thing that I need for merit is one of these half equations. So again, it's an or option. Okay? So do both of them, so you have 2 chances, but the good news is I'm going to try to design the assessment so that way you always have one easier one, so that way you will be able to get merit hopefully easily. Are we okay with that so far? All right, shall we do the excellence? It's real easy once you get to this point. All right, we've done this much work, I might as well get to the excellence. Okay, so several things for the excellence. The first thing is that this is no longer an or option, it is an and option. I need to see both justifications.
Oh my goodness.
The other thing for the excellence is it's an and option here. You need to have both half equations.
Oh my goodness.
And then the last thing for excellence is we need to put together both half equations. What you're going to do is you're going to check your electrons, and we need the electrons to cancel out. So I need to make sure that these 2 are the same number. This is 2, and that is 1. So I'm going to multiply this whole equation by 2. So that becomes a 2, that changes to a 4, that becomes a 2, that becomes a 2, and that becomes a 2. And then the last thing I do is I put it all together. So the electrons should cancel out, and then I just put together my equations. Now again, I like to organize it so that way I have my arrow in the center, so that way I can very easily just copy this stuff down and then copy that stuff down. So I have copper, I have 4 hydrogens, I have 2 nitrates. On this side I have copper, I have 2 nitrogen dioxides, and I have 2 waters. And that's how you do it. And that's how you get up to excellence. Sorry, got an itch in my nose. All right, what questions do you have? All right, I don't want to do another example because I want you guys to have a chance to practice it, because by practicing it, I can then catch those mistakes. Yeah? So what I'm going to do is I'm going to put the practice questions back up on the board for you guys. If you're having a hard time reading it, I have linked them onto my Google site, so you can always just look them up on your computer. I have printed lots of extra copies of the template that you're going to be using for the assessment. So if you want to grab a couple of extra ones, you can. Obviously, I've double-sided the ones that you guys have done. Feel free, obviously, to call me over when you have things ready for me to check. The other thing you can do is you can drop things into my blue box, and I'm happy to mark them and give them back to you, or I won't see you guys before the assessment, so I can scan them and let you guys see what your answers are like. Cool. All right. And then obviously grab a treat once you get a question done. Cool. All right, let's hop to it.